For question 3, we're given a random variable x, which is normally distributed, except this time it's not standard normal. It has a mean this time equal to 20 and a standard deviation of 5. And we want to find some probabilities associated with it. Now remember that in order to use our z-table, this handy table here for calculating normal probabilities, we need to have a standard normal distribution. Remember that a standard normal random variable has a mean equal to 0 and a standard deviation equal to 1. We don't have that in this case, so how do we use our z-table? Well, for any normal random variable, we can convert it to a standard normal. To convert, we use our formula that says z is equal to x minus the mean over the standard deviation. So for part A, we want the probability that x is between 22 and 31. This is equal to the probability that z is between two converted values. So we convert 22 to a z-score, and we convert 31 to a z-score. So to do that, we just use this formula here. So we take 22 minus the mean of our random variable, which is 20, divided by the standard deviation, which is 5. And we do the same to 31. We take 31 minus the mean over the standard deviation. And so now we just want to calculate these values, turn them into decimals. So, let's see, let me plug this into my calculator. So if I plug this into my calculator, 22 minus 20 over 5 is 0.4. And 31 minus 20 over 5 is 2.2. To find the probability that z is between two values, to remind us how to do that, I'll draw a picture. I want this shaded area in the middle. Using the z-table, now that I've converted these to z-scores, I can use my z-table. The z-table will give me the area all the way to the left of 2.2. I just want the shaded area, so I'll subtract out the area I don't want, which is the area to the left of 0.4. So this is equal to the area to the left of 2.2 minus the area to the left of 0.4. I can find these areas from my z-table. So for 2.2, that's 2.20, so I'm going to go here. So that area is 0.9861. Area to the left of 0.4. 0.40, so that's this right here, 0.6554. I can plug this into my calculator, and I should get that the area in the middle is 0.3307. Now for part B. Part B, I want to find x such that the area to the right of it is 0.7. That's the same thing as finding, let me draw a bigger area here. That's the same thing as finding the z-score with an area to the right of 0.7. So I know the area to the right is 0.7. That's the same thing as saying that the area to the left is 1 minus 0.7, which is 0.3. So I want to find the z value such that the area to the left is 0.3. So I'll look for 0.3 among the areas in my table. Let's see how close we can get to 0.3. Let's see, I have 0.2981 and 0.3015. We can take, well, this one's a little closer. So I'll take 0.3015. So that corresponds to a z-score of negative 0.52. Negative 0.52 corresponds to an area to the left of approximately 0.3. So I know that z is equal to negative 0.52. So I know that z is equal to negative 0.52, but remember the question wanted us to find x such that area to the right is 0.7. So all we have to do is convert. We know that c is equal to x minus its mean over the standard deviation. I can rearrange my variables here to get that x is equal to the mean plus the standard deviation times the corresponding z-score. So to convert from the z-score to x, I'll just plug in my mean, standard deviation, and z-score. I know that my mean it gives me is 20, and the standard deviation given to us was 5. Plug in z. Then I can plug this into my calculator and see what I get. Negative 0.52. I should get about 17.4. So I know that the x value, such that the area to the right is 0.7, is exactly 17.4.